Hi, this is a presentation about ClimaCheck on-site software, which is a PC software used with the ClimaCheck on-site hardware. Now, the demonstration of this software will be done in a separate video. Now, what is the ClimaCheck on-site software? It is a performance analyzing software. We have input data, temperatures, pressures, electrical power. We get out KPIs and other parameters that will allow us to analyze the performance of our system. When to use the analyzing software is during commissioning, measuring, validation, maintenance, and troubleshooting. Now, during commissioning, we would like to know if our system is installed properly, if it's behaving properly as expected. We can do measuring and validation. We can check what the manufacturer recommends about the performance and how our system is actually operating. We can use the on-site software during maintenance. So every time we're out to the site doing checks on the system, it is a good time to check the performance with the ClimaCheck on-site software. And we can do the analysis during troubleshooting. So if we know that there's a problem with our system, then we can measure with the ClimaCheck on-site software and see when the fault occurs and what it is causing. It's important to know why we're doing the measurement. It will be different types of measurement depending on why we're doing the measurement. Troubleshooting, we have to wait for the fault to occur. During maintenance, we're there maybe a few hours and we do the measurement during these few hours. During measuring and validation, we might want to do the measurement in different situations to have different loads, different ambient conditions. So it's important to know the objective of the measurement. It's important to know the type of the system. We will have different types of measurement if we have a system with economizer or a system without an economizer. We will have a different type of measurement if we have two-circuit system. We will have a different type of measurement if we have an air-cooled system compared to a water-cooled system. So it is important to know the type of the system that we're measuring and the boundary conditions. We would like to know if it's a heat pump, then we would like to measure during winter. We would maybe like to know how it is operating during the coldest days, or maybe how it is operating during the fall when it's not so cold outside. So these are two different measurements, and this will dictate how long we would like to do the measurement. If it's a problem that we're looking for, then we need to measure until that problem occurs. If we're looking for the system, how it operates during a week, if it has different fluctuations in the loads and different ambient temperatures, we need to include these in our measurement. So how does the ClimaCheck on-site software is structured? So we have a template, and in this case, this is the calculation method. Now I mentioned that it will be a different type of measurement if we have a one-circuit system or a two-circuit system. If we have a system with economizer, or maybe if we have a system with oil cooling on the compressor, then we will have different type of calculations. And this is set up in the template. We need to use the correct template with the correct type of measurement. So we need to know what it is we're measuring, and we need to choose the correct template for that. We have different templates for different types of systems. Choosing the template we need to know what points to measure. For different types of systems, we will have different points to measure. If it's a 2-circuit systems, we will need to measure the 2 circuits. If it's an economizer, then we will need to measure the intermediate pressure, and we will have extra data. So we need to know what it is we're measuring and which points to measure. We also need to know which sensors, which input channels we're using for each measurement point. For example, we need to define that, okay, temperature 1 is being used for the discharge temperature on the compressor. We need to define that temperature 2 is being used for the suction temperature, and so on. This is done in the data source. In the data source, we define which points we're measuring and which input channels we're using to measure these points. Together with the template, the data source form the workbook. And the workbook is what you would see when you open the software. So in that case, you will need to decide the template, which system you're measuring. Is it a 1-circuit system with just a compressor, condenser, expansion valve, and evaporator? Or maybe it has also an economizer. Maybe it has an oil cooling. This needs to be defined in the template. When defining the template, we would also need to check the data source. Which measuring points we need to have, and which input channels we're using for these measurement points. This is defined in the data source. And when we have defined the template and the data source, we will have the workbook. When you install the ClimaCheck software, you will have 3 different shortcuts to open the software. Now we have the ClimaCheck standard, and in this one, software preloads 1-circuit template and the data source for the ClimaCheck on-site hardware, the PA Port 3. Now this is predefined, so it makes it easier to start the measurement. In this case, we need to actually be sure that what we're measuring is a 1-circuit template, 1-circuit system. And we actually have a PA Port 3 that we're using to measure the points. If not, then we have to change the template and the data source. ClimaCheck Advanced, it has no preloaded template or data source. So when you open ClimaCheck Advanced, it will ask you which template you would like to use. After choosing the template, you would need to choose the data source that follows the template. Finally, we have the ClimaCheck demo, and this is used for demonstration purposes. It basically has data from previous measurement. So we have done a measurement at some point, and we use that data to just demonstrate how the software works. I'll be using that in the ClimaCheck software demonstration. So what we need to know here is that we need to have a combination of template and a data source. Now each template that we send, or each template that we include in the software, it will have a corresponding data source. Each template will have different measurement points, so it will have a separate, unique data source. And with that follows instructions. Instructions basically will say which points to measure and which input channels to use to measure these points. When measuring these points with the said input channels, then we can just use the provided template and the data source. Now the first thing that we get when we open the software is a system setup. In here, we can write about equipment, some description about manufacturer, compressor manufacturer, and so on. What's also important here is to choose the system type. What it is that we're measuring. Is it a water-cooled chiller? Is it an air-cooled chiller? Is it a supermarket? And so on. Why this is important is because it defines the SEI reference temperatures. The reference temperatures will be different if it's a water-cooled system or an air-cooled system. So if we choose this system type, the reference temperatures will be calculated correctly and the SEI will be calculated correctly. So what we need to do, if we start with the ClimaCheck standard, then we already have one circuit system template and the data source. So in that case, you will need to connect the hardware, ClimaCheck on-site hardware, the PA Pro 3, to the laptop with a USB cable. You will also get a reminder of the refrigerant. If you want to change the refrigerant, then you can do that from the refrigerant menu. Finally, we click on Contact and Direct. This means that we have direct connection with our hardware. We have direct connection with our sensors. The alternative would be that we would rerun some of the data that we've measured previously. In that case, there won't be any hardware involved. So to do the basic measurements with ClimaCheck standard, we open ClimaCheck standard. It already opens the one circuit template and the corresponding data source. We connect our hardware to the laptop. We choose the refrigerant. We click on Contact and Direct. Finally, we click on the Start button and the measurement will start. At that point, you can start checking the sensors if they're connected properly, if they're giving reasonable values. So we see in the software are 10 tabs and the data source tab. Now we'll go through each of these tabs and explain what we have. We have the script, it's a description. So this is all the information we've included in the system setup at the beginning. We have the report, and this is a spreadsheet with calculated and measured values. We have the constants tab, where we're using all the constants to do the calculations. We have the input, where we see all the incoming values from our sensors. The custom tab will give us a nice sheet to compare measured values to nominal values. We have the flow chart, where we see real-time values of the measurement, graphs to do the analysis, and a dashboard that shows the SEI values and the KPIs. So the report tab will show the data in table form. And here we will see the measured values and the calculated values. This is updated as soon as a new data set comes in. So if we've set up that we want the new data coming in every minute, the report tab will be updated every minute with incoming data and calculated values. It will show the KPIs and indicate if there is any deviation from a set limit range that we've put. So this is how the report tab looks like. Each of these rows represent a new data set. So in this case, we've set up that we want to receive data every 5 seconds. So every 5 seconds, we've got a new data set. Each of these columns represent a value. Now these values can be input values. For example, the first two in here are the chilled water in and out. And the third one is a calculated value, which is a difference between those two values. For each of these values, we're able to see span during the last 20, 40 data points, the average, maximum, and minimum. We can also set up limits for these. So we know that the difference between chilled water in and out should be between 3 and 6. And if it's out of the limits, then it will be turned red. The value will turn red. In this case, we have a limits on the superheat that needs to be between 4 and 7. And here we've got 3.6, which is outside the limits. Then we have a red value. Each of these ranges have some comments explaining why you would have out of range values. What might be the cause for that? We can add notes to each cell. So if we know that something happened at this point of time, then we can make a note of that, so that when we're doing the analysis, we can see the note and know what to expect from the system. Maybe change from full load to part load, and we would like to make a note of that. Now the next tab is the constants tab. And here we have constants that we're using in the calculations. Now I'll go through some of the important ones that you have to think about when doing measurement. Now the first one is a minimum compressor capacity to log. So this one basically, we input a value, and if we have a compressor power above this value, then we will log that. Now by default this is set to negative value, which means we will log every single value that comes in. The next one, it defines the limit above which we calculate the COP and all the KPIs. So default value is 0.5 kilowatts. This means when we measure compressor power higher than 0.5 kilowatts, then we will calculate the COP and the efficiencies. But if we have a value below 0.5, if we have some small currents that are there even though the compressor is turned off, then in that case we don't need to calculate the COP. The compressor is turned off. This is important because if you're measuring on small systems, if you know that your system is using generally 200-300 watts, then you need to change this value to something like 0.1 kilowatts so that you get all the COPs and the efficiencies for your system. A third one is a thermal efficiency compressor of the compressor, and this is set by default to 93%, 0.93. And this means that whatever electrical power that goes into the compressor, 93% of it goes to the refrigerant cycle. This is important because all compressors will have some heat loss. Not all the energy, the electrical energy, will go into the refrigerant cycle. Some of it will escape. Now the default value of the heat loss is 7%. So we're saying that 7% of the electrical power that goes in is dissipated as heat loss. If you know that your compressor has active cooling, if it sits in front of a fan or there's actually a fan just to cool the compressor, then this value needs to be changed. We no longer have 7% heat loss, we have much more heat loss. Now, next set of data is when we have external motor on the compressor. Now if we have an open drive compressor and we have a motor, then there will be some losses in the transfer from the motor to the compressor. Now default this is 1, we're assuming there is no external motor. But if you have an external motor, then we have some guide on what to set this value to. Here we can also include the losses from the variable frequency drive. Now, if there is a VFD in the system, then we will have 2-3% losses. In that case, you can set it up in the external motor efficiency. So in that case, you would put, instead of 1, you would put 0.98. Finally, in the constants, we have the properties of the secondary fluids. Here, we're defining the specific heat and the density of the secondary fluids. Now, this can be the water or glycol on the cold side, or water or air on the warm side. These data are used to calculate the flow on the secondary side. These are not used to calculate the COP capacity or efficiency. Because ClimaCheck uses the internal method, then we are not using these secondary temperatures to calculate the COP. But we do use the CP and the density to calculate the flow on the secondary side. Here we also have the reference temperatures, which are used in the SEI. And these are adjusted automatically when we select the system type. So this is not something you need to change, but you need to make sure that you chose the correct system type when opening a template. The next tab we have is the Input tab. Here we see all the relevant values to this template, so all the measuring points that we have, and the data that we're measuring. So whatever the sensor is sending, it will be shown in here in the raw data. What we can do in this tab is to have an offset to this data before using it in the calculations. Why we might need this? We might need, for example, if we have extended the temperature sensor, it will show a degree or decimal higher than what it actually is because of the cable resistance in the extension. And in that case, we need to have an offset on this temperature. So we can say that, okay, we are measuring 8.1, but we know that there is a 0.2 degrees difference, an extra resistance in the cable, then we can set an offset of 0.2. And in the calculations, we will not use 8.1, but we will use 7.9 instead. Another use for this tab is when we're measuring only one of the phases of the compressor. Now, compressors will have a 3-phase power, but for some reason we might decide to measure only one of them. For example, if we have several compressors and we only have one power meter, and we might decide just to measure one of the phases. In that case, because we're only measuring one of the 3 phases, then we need to multiply this value by 3. So the electrical power is set in here, and we can change this 1 to 3 to multiply this 19 by 3 and using that result into the calculations. Now next we have the custom sheet, and in this case we can have a comparison between the measure values and the nominal values. This will give us a nice sheet where we have the measure values and some baseline or nominal values that we can compare to. Now this sheet is something that can be printed and saved each time we do our maintenance. So we know that we do maintenance on this system every 6 months, and we come and input whatever we had last time and compare it to what we have now to see if there are any differences. We can print this sheet and hand it to the customer to show that we've done the measurement and what we got as results. Next tab is the flowchart, and the flowchart will be customized depending on the type of system that we have. In this case, we have a one circuit system, a compressor, condenser, expansion valve, and evaporator. And if we have a system with two circuits, then we will have a flowchart with two circuits. And in here we have real-time values. So we need to think about that this is the last value that has arrived to the software. It might be a good data to represent our system, but it might also be when the system has just been starting and maybe not used as a representative data. So in here we have the live data from the sensors, temperature, pressure, electrical power. But we also have the SEI and the sub-efficiencies, compressor, condenser, and evaporator. Next we have the graph tabs, and this will help in knowing how the system is operating, if it's a stable system, and how it's changing over time. Now the graphs is a main part where we do our analysis. We can compare different KPIs, see how they're changing over time, what variable is affecting which other KPI. So we will be able to see it in the graph tabs. And there are two graphs. The idea is the same in both graphs, but we will have different variables. And we're able to change these variables to whichever variable that we want. We will do that in the demonstration and the exercises. When you hover on the graph, you will see the values of all the variables that are chosen. And you can also decide to zoom in into a part. To do that, you need to hold Shift on the keyboard and choose the part that you want to zoom in. You can decide to change the variables, to change the colors, to change the decimal points. And you do that by clicking on Data Setup. And here you can decide which variables you want to show in general and the colors. Finally, we've got the Dashboard tab, and in here we're showing the SEI, the System Efficiency Index, the sub-efficiencies, and all the relevant KPIs to these sub-efficiencies. On the first part, we have information about the system that we're measuring, and this is directly taken from the system setup at the beginning of when we open the template. Next, we've got a small graph to show how the system is operating. When doing any kind of analysis, it is important to show data from a stable system. For example, in this case, we have an operation at this part, maybe it is part load, and at the next stage is going up to full load. It might be a good idea to show both parts. It will not be a good idea to pick up the data which is in this part. In this part, the system is ramping up to another load, and that is not a representative data. Ideally, we would have a stable operation, and we can pick where we want to look at the SEI. Now the SEI is shown in here, and we have the sub-efficiencies with the KPIs related to each sub-efficiency. If we have an issue in the SEI, if it's in orange, then we can go in here in each sub-efficiency and know which part is actually affecting the performance. And when we know that, for example, it's the condenser, then we can go into the KPIs and see which part it is that actually is causing the issue. Now this dashboard is a very good place to take a screenshot and to include in the report. It basically summarizes the whole measurement. We can pick a representative data and show the SEI and talk about each part of the system. What we noticed when we did the analysis, what we recommend to improve the system. It's important to know the limitations when using the on-site software compared to a monitoring tool. The on-site software is limited in time. We're doing the measurement maybe a couple of hours, maybe a couple of days, and there's a goal, an objective with that measurement. And the objective is not monitoring. So we will not have any alarms in the system. If there is any issue, we will not get emails and so on. It is difficult to predict faults, so if we're doing troubleshooting, we would need to wait for the fault to occur. We're not monitoring, we will not see if a fault occurs. We need to be there during the measurement. And compared to a monitoring tool, we are not doing any energy analysis because we are measuring in a shorter period. Now we will do a full demonstration of the software in the next video. Thank you.